Manage capacity. Azure Stack Hub uses two considerations when placing virtual machines. One, is there enough memory on the host for that VM type? And two, are the virtual machines a part of an availability set, or are they virtual machine scale sets? To achieve high availability of a multi-VM production workload in Azure Stack Hub, virtual machines are placed in an availability set that spreads them across multiple fault domains. A fault domain in an availability set is defined as a single node in a scale unit. Azure Stack Hub supports having an availability set with a maximum of 3 fault domains to be consistent with Azure. VMs placed in an availability set will be physically isolated from each other by spreading them as evenly as possible over multiple fault domains or Azure Stack Hub nodes. If there's a hardware failure, VMs from the failed fault domain will be restarted in other fault domains. If possible, they'll be kept in separate fault domains from the other virtual machines in the same availability set. When the host comes back online, VMs will be rebalanced to maintain high availability. The hyperconverged infrastructure of Azure Stack Hub allows for the sharing of physical storage devices. There are 3 main divisions of the available storage that can be shared: the infrastructure, the temporary storage of the tenant virtual machines, and the storage back in the blobs, tables, and queues of the Azure Consistent Storage Services. The Azure Stack Hub infrastructure directly allocates and manages all storage capacity. The operator doesn't need to make choices about configuration, allocation, or capacity expansion. Azure Stack Hub automates these design decisions to align with the solution requirements during either the initial installation and deployment or capacity expansion. Azure Stack Hub takes into consideration resiliency, reserved capacity for rebuilds, and other details as part of the design. Operators can choose between either an all-flash or a hybrid storage configuration. The Azure Stack Hub Capacity Planner is a spreadsheet that shows how different allocations of computing resources would fit across a selection of hardware offerings. The following table describes each worksheet in the Azure Stack Hub Capacity Planner, which can be downloaded from https://aka.ms/AZ-Stack-Capacity-Planner. Make sure you review either the spreadsheet or the link provided to understand the different tabs at the bottom. For example, the Define Solution SKUs instructions versus Defined by VM Footprint or Defined by Workload Footprint. You can choose from 3 GPU models in the public preview period. They are available in NVIDIA V100, NVIDIA T4, and AMD MI25 GPUs. These physical GPUs align with the following Azure N-Series virtual machine types as follow: NCV3, NVV4, or NCAS T4 V3. Note that these VM sizes can't be deployed using the Portal User Interface UI. You can use Azure PowerShell, Azure CLI, or Azure Resource Manager templates. The Azure Stack Hub storage infrastructure allocates a subset of the total storage capacity of the Azure Stack Hub deployment as storage services. Storage services store a tenant's data in shares on volumes that correspond to the nodes of the deployment. Azure Stack Hub only supports the expansion of storage capacity by adding additional scale unit nodes. Adding physical disks to the nodes won't expand the storage capacity. It's important to monitor the available storage to ensure the efficient operations are maintained. When the remaining free capacity of a volume becomes limited, plan to manage the available space to prevent the shares from running out of capacity. Your options for managing capacity include reclaiming capacity, migrating storage objects. Be sure to review the article to understand volumes, shares, containers, and disks. When it's necessary to free space on a volume, use the least invasive methods first. For example, try to reclaim space before you choose to migrate a managed disk. You can reclaim the capacity that's used by tenant accounts that have been deleted. This capacity is automatically reclaimed when the data retention period is reached, or you can act to reclaim it immediately. You can add public IP addresses to your Azure Stack Hub system at any time after the initial deployment of the Azure Stack Hub system. At a high level, the process of adding a new public IP address block to the Azure Stack Hub looks like this graphic. Full and express updates, hot fixes, as well as driver and firmware updates from the OEM all help to keep Azure Stack Hub up to date. There are three types of update packages for Azure Stack Hub integrated systems. Azure Stack Hub software updates. These packages can include the latest Windows Server security updates, non-security updates, and Azure Stack Hub feature updates. You download these update packages directly from Microsoft. Each update package has a corresponding type, full or express. Full update packages update the physical host operating systems in the scale unit and require a larger maintenance window. Express update packages are scoped and don't update the underlying physical host operating systems. Azure Stack Hub hotfixes. Microsoft provides hotfixes for Azure Stack Hub that address a specific issue that's often preventative or time sensitive. You would download and install hotfixes just like the regular full update packages for Azure Stack Hub. Hotfixes are cumulative and can install in minutes. OEM hardware vendor provided updates. Azure Stack Hub hardware partners are responsible for the end-to-end servicing lifecycle, including guidance for the hardware-related firmware and driver update packages. Once you know you have an update, apply it by using the following steps. 1. Plan for the update. Be sure to follow all the steps in the Azure Stack Hub pre-update checklist to ensure that you've completed the required prerequisite for applying an update. 2. Upload and prepare the update package. For internet-connected Azure Stack Hub environments, Azure Stack Hub software updates and hotfixes are automatically imported into the system and prepared for the update. For internet-disconnected Azure Stack Hub environments and environments with weak or intermittent internet connectivity, update packages are imported into Azure Stack Hub storage via the Azure Stack Hub Administrator portal. All OEM update packages are manually imported into your environment regardless of your Azure Stack Hub system's internet connectivity. For more steps to import and prepare the update package, see Upload and Prepare an Azure Stack Hub update package. 3. Apply the update. Apply the update using the Update blade in the Azure Stack Hub portal. During the update, monitor and troubleshoot the update process. For an Azure Stack Hub instance to remain in a supported state, the instance must run the most recently released update version or run either of the two preceding update versions. There must be an active support agreement with a hardware partner that manufactured the system. Microsoft is not able to support you without a hardware support agreement in place. Hotfixes aren't considered major update versions. For a disconnected system or systems with weak internet connectivity, update packages can be downloaded using the Azure Stack Hub Updates Downloader tool. The Azure Stack Hub software update packages may contain updates to Azure Stack Hub services and updates to the operating system of your Azure Stack Hub's scale units. The update package itself and its contents, such as binaries, PowerShell scripts, and so on, are signed with Microsoft-owned certificates. Tampering with the package will make the signature invalid. The following steps outline how to manually import and update the packages from the portal. 1. In the Administrator portal, select All Services, then under the Storage category, select Storage Accounts. Or in the Filter box, start typing Storage Accounts and then select it. 2. In the Filter box, type Update and select the Update Admin Account Storage Account. 3. In All Services, under Essentials or Blob Services, select Containers. 4. In the Containers, select the Plus container to create a container. Enter a name, for example, Update-2102, and then select Create. 5. After the container is created, select the container name, and then select Upload to upload the package files to the container. 6. Under Upload Blob, select the folder icon, browse to the update package zip file, and then select Open in the File Explorer window. 7. Under Upload Blob, select Upload. Repeat the upload steps for the metadata.xml file and any additional zip files in the update package. Don't import the supplemental notice.txt file if included. When all done, a notification should indicate that the upload is finished. You go back to the update blade on the dashboard, which should show that an update is now available. To install the update, select the package that's marked as ready and then select the Update Now. When the update finishes, the update blade shows the updated Azure Stack Hub version. You can manually delete updates from the storage account after they've been installed on Azure Stack Hub. Azure Stack Hub periodically checks for older update packages and removes them from storage. It may take Azure Stack Hub up to 2 weeks to remove the old packages. As an Azure Stack Hub operator, you should use the Administrator Portal, PowerShell, or Azure Resource Manager APIs for most day-to-day management tasks. However, for some less common operations, you need to use the Privileged Endpoint, or PEP. The PEP is a pre-configured remote PowerShell console that provides you with just enough capabilities to help you do a required task. The endpoint uses PowerShell GIA, or just enough administration, to expose only a restricted set of commands. To access the PEP and invoke the restricted set of commands, a low-privileged account is used. No admin accounts are required. For additional security, scripting isn't allowed either. You can use the PEP to perform these tasks. Low-level tasks such as collecting diagnostic logs. Many post-deployment data center integration tasks for integrated systems such as adding DNS forwarders after the deployment, or setting up Microsoft Graph integration, Active Directory Federation Services integration, certificate rotation, and so on. To work with support to obtain temporary high-level access for in-depth troubleshooting of an integrated system. The PEP logs every action and its corresponding output that you perform in the PowerShell session. This provides full transparency and a complete auditing of operations. You can keep these logs for future audits. Pause the video to make sure you review all the commands shown before they disappear. They include the steps for creating a support session that you would do with the Cloud Admin account. Once you're in the Privileged Endpoint, there are additional commands that can be run to configure the Cloud Admin account. These include new-cloud admin user, remove-cloud admin user, and set-cloud admin user password. It's important to properly shut down and restart Azure Stack Hub services. Stop will physically shut down and power off the entire Azure Stack Hub environment. Start powers on all infrastructure roles and returns tenant resources to the power state they were in before the shutdown. The Azure Stack Hub validation tool, or test-Azure Stack, is a PowerShell commandlet that lets you run a series of tests on your system to identify failures if present. You'll typically be asked to run this tool through the PEP, or Privileged Endpoint, when you contact Microsoft Customer Services Support with an issue. With the system-wide health and status information at hand, Microsoft Support can collect and analyze detailed logs, focus on the areas where the error occurred, and work with you to fix the issue. The Azure Stack Hub validation tool, test-Azure Stack, is a PowerShell commandlet that lets you run a series of tests on your system to identify failures if present. You'll typically be asked to run this tool through a PEP session when you contact Microsoft Customer Services Support with an issue. With the system-wide health and status information at hand, Microsoft Support can collect and analyze detailed logs, focus on the area where the error occurred, and work with you to fix the issue. There are many possible tests to run, for example, update summaries, Active Directory summaries, and more, so make sure to review those links. In addition to the infrastructure tests, you can also run cloud scenario tests as shown in the graphic to check functionality across infrastructure components. Cloud admin credentials are required to run these tests because they involve resource deployment. Note that you can't run cloud scenario tests using Active Directory Federation Service credentials. That's a wrap, folks. To find all the resource links as shown or discussed in all these modules, just search for Thomas Mohrer's AZ-600 study guide blog, where he links every article to each exam objective. We hope this video study guide helps you with yet another method to study and learn these Azure Stack Hub concepts. Good luck with that, and ciao for now. Cheers.